All right, in this video lecture, what we're going to do is we're going to talk about representing the supply and demand functions as mathematical equations and getting solutions from there. So that instead of using the graphs, now we're going to be able to represent these same ideas and concepts of the supply curve moving around or the demand curve shifting out. We're going to be able to represent that with mathematical terms, and we're going to look at on into the future what happens when a tax or a subsidy is put in place, and how do we get equilibrium, prices and quantities, all by using the tools of mathematics, which is just simply a different way of representing the supply and demand functions as opposed to having the demand curves graphically. Now we have them in equation form. So let's kick it off and go through a couple of examples, a couple of questions, so that you can see how you solve for supply and demand when you use mathematical tools as opposed to the graphical tools. All right, so to kick things off here, I have two equations for you. One is P equals 9Q plus 3, and the other is 2Q plus P equals 12. One of these is a supply curve, and the other is a demand curve, right? And I'm asking you here, which one is which, right? Which one of these is a supply curve, which is a demand curve, right? And one thing that you could do is you could simply look at what happens when quantity increases, and then kind of think about what's going on in each of these. So if quantity is going up in the first one, what happens to the price? Right? So the more that we increase the Q here, the larger and larger the price will end up being. If Q is 10, the price is going to be 93, right? But if you throw in a Q of 200, the price is going to be a lot higher. So it seems that as Q goes up, P goes up. Well, we know that price and quantity go up in supply curves, right? And then you could do the opposite or the same thing and get the opposite result in the other equation there. You could look at it and say, okay, well, we have 2Q. As Q keeps going up, what happens to P? But now, we'd have to rearrange the equation a little bit to see what's going on, at least to do it easily, right? And so what you could do is you can move the price over to the other side, or you can move the quantity over. You could do different things. However it is easiest for you. As long as you follow the rules of algebra, everything stays the same. One note here is that when we solve for Q equals, and then we have the rest of the equation on one side, that's a standard way of putting forward a supply or demand function in economics. That's the norm. But then we have what's called the inverse supply function or the inverse demand curve. And that's when we set it P equals. So the first function that is listed, P equals 9Q plus 3, that's the inverse supply curve. If we solve for Q, that's the standard supply curve or demand curve as it goes. So you can change the demand curve to P equals 12 minus 2Q, and you have the inverse demand curve as well. And you can see that relationship between price going up and quantity going down a little bit easier. All right, so for our next question here, we're going to actually try and solve. So now let's let demand be given by P equals 10 minus Q. So we have the inverse demand curve. And let supply be given by P equals Q. Okay? And what we want to know is, what is the equilibrium price? And what is the equilibrium quantity? Okay? So we're going to try and solve both of these, the price and quantity. So to figure out the answer, we start with our demand curve and our supply curve. And then in equilibrium, we must note that the quantity supplied has to equal the quantity demanded. Unless there's some intervention in the market or something that's preventing these two things from being equal, then the equilibrium outcome, there's only one quantity, right? The quantity that we sell is the quantity that is purchased. And so we know that these two things are equal. That's going to be a really important condition for us in moving forward to solve the mathematical formulas that we need. All right, so then we can look at the equations that we have and we can say, okay, well, we know that the demand function we can rewrite that in a standard form as Q equals 10 minus P. We wouldn't have to do that here, but just for practice for other problems, it's actually going to make sense for us in the mathematical solutions to always set it to a standard economic form, not the inverse demand curve. The inverse demand curve or the inverse supply curve, they're nice for understanding the kind of slope of the graph. But when it comes to solving the mathematical equations, a nice easy cheat for us for some of the other processes that we're going to do is to always just start out and set these things equal to Q. In part because we have this condition where quantity supplied equals quantity demanded. So if we set our demand equation up equal to Q, we get it to Q equals 10 minus P, and our supply, we get this Q equals P, right? Well, from this, what we know is, okay, quantity supplied equals quantity demanded. And so if Q quantity demanded equals 10 minus P and quantity supplied equals P, then we know that those two equations are also equal to each other. So that we just kind of squish all of this stuff together, right? We can look at this equation that we have here and realize that those are all equal to each other, right? Because this is the quantity supplied and this is the quantity demanded, right? And so all of that is equal to each other. So we can isolate the price variable by just kind of squishing those equations together and reducing that down. So we have 10 minus P equals P. And then from this, with only one variable, now we can actually solve the equation, right? And we can get 10 is equal to 2P, and then P equals 5. So you have a price of 5. And now that you know your price, what you can do is just kind of plug it back into the equations that you have. So let's just take this answer here and plug it back into this equation, right? And figure out what our quantity is. So if price equals 5, plug it back in to that demand function, and we can see that quantity also equals 5. And so we've solved our first problem. All right, let's do another supply and demand equilibrium. In this case, consider a market whose supply and demand curves are given by P equals 4Q. Is that our supply or our demand? Is it an inverse or standard equation? Right, you should see that as price goes up, quantity is going up. And so that is a supply curve, right? And then we should also see that it's P equals, so it's our inverse supply curve. And then we also have the other equation, P equals 12 minus 2Q. That's our inverse demand curve. And the question states, what will the market equilibrium price and quantity be given this setup, right? So to answer this, we have our supply curve, we have our demand curve. What we want to do is we want to set those equal to Q because we know that condition of quantity supplied equals quantity demanded is going to be a nice condition for us all throughout. Is there shortcuts to solve other ways where it's we just have the prices equal to each other and smush the equations together? It will work now. It won't work in the long run when we start doing things that are more advanced with taxes and subsidies and other things. So we're going to solve for Q for each of these equations. So we say that the supply curve now is, the standard supply curve is Q equals P over 4. And the demand is Q equals 12 minus P divided by 2. We know that those two quantities, right, are equal to each other. So both of those are equal to each other. And that means that what they're equal to is equal to each other as well. So that P over 4 has to also equal this 12 minus P over 2. And so we get that next line of the equation here simply by knowing that quantity supplied equals quantity demanded and just kind of combining all of the equations. We get that P over 4 is equal to that 12 minus P divided by 2. And now we only have one variable. So from this, we can solve just by reducing everything down, right? And so what we end up with is we can say, okay, let's multiply both sides by 4 and reduce from there, factor everything through, and we get a price equal to 8. And so once price equals 8, then what we can do is once again take that price and plug it back in to our original equation. We could plug it back into either, but I'm just kind of going with the first one that's listed. And what we can do is then solve for the quantity, right? So it's a pretty simple process here, is take your supply function, take your demand function, set them both equal to Q. Then you have a quantity supplied equals and a quantity demanded equal. And we know that those two things have to be equal to one another. So we can kind of smush those equations together. So we can say, okay, we know quantity supplied equals quantity demanded. So once we set our equations equal to Q, we can combine those equations. Then we can reduce down because only one variable, price, will be left. With only one variable left, we can solve for price. Then once we get the answer for price, we can plug it back into the original equation, and what we have is a solution for the quantity as well. All right, so a little challenge question here. Consider a market whose supply and demand curves are given by Q equals minus 25 plus P and Q equals 50 minus 0.5 P respectively. Okay. Is this market in equilibrium if the current price being charged is $40? If not, do you expect the price to rise or to fall, and by how much? Also, is there excess demand or excess supply? Given your background in economics and what we've covered so far with the equations, you might be able to solve this now. So if you want, go ahead and give this a pause and try and solve, see where the equilibrium is, maybe draw this up a little bit and get a rough sketch and see if the market see if we can answer the question, is the market in equilibrium if the current price being charged is $40? And then if not, do you expect the price to rise or fall? And currently, if the price being charged is $40, is there excess demand or is there excess supply? Here's the answer to that challenge question. So the first thing that you would do is you say, okay, we got to set both our equations equal to Q. We already have that, it's given to us. We know that in equilibrium, quantity supplied equals quantity demanded. So what we can do is, the second step is we can kind of smush those equations together. So we can say that we have that minus 25 plus P is equal to 50 minus 0.5 P. And then from there, now that we have just one variable isolated, we can go on to the next step and we can solve this equation with just one variable. We can reduce everything down. In this case, the equilibrium price is $50. At least that's what it should be. So the equilibrium price is $50. Yet we were told that only $40 is being charged. At this price, more people will be demanding the item than the producers are making. Right? At $40, when the equilibrium should be 50, we're going to be purchasing a bunch, and so excess demand will occur, and thus we'll expect the price to rise about $10 until it reaches its equilibrium point. All right. If you follow this same basic pattern, you should be able to do the simple supply and demand equation analysis of coming up with solutions for equilibrium price and quantity. You follow 4 simple steps, right? Set the equations equal to Q. Knowing that quantity supplied equals quantity demanded, we bring the equations together then. And then the next step would be reducing down and solving for one variable. And then the final step is just plugging that variable back into the original equation and figuring out the other variable.